Hello viewers, welcome to the class for today. Today we want to look at equations of motion in physics, and this is grade 11 physics, precisely SS2 in Nigerian curriculum. My students will join now. You can subscribe to this channel. Thank you.
Hello, sir. Can you hear me, sir?
Oh, right, I can hear you.
Good afternoon, sir.
Yeah, you're welcome to class for
What?
today. Okay,
Hold on a bit, sir.
okay, no problem.
Oh,
Okay, I think you should be able to see the screen now. Okay, then you can start your video.
do you get?
Yes, can you hear me clearly?
Yes, I'm trying to connect the laptop to the
Okay,
system to the TV's board.
okay, no problem. No problem. Right. We're going to move on shortly. The topic for today, like I said, is equation of motion. Please, can you hear me clearly?
Yes, sir.
Okay, very good, very good. So, talking about equations of motion, we have three basic equations of motion which we are going to try to derive today. But please don't write anything until I ask you to write, okay?
Yes, sir.
All right. So, there are three basic equations of motion. And okay, let me just list them. So the first one, we have v equal to u plus at, and the second one we have s equals to ut plus half at squared. Then the third one, we have v squared equals to u squared plus 2as. So when you have questions that has to do with linear motions, okay? Linear motions, these are the equations that you can use to calculate whatever you has to find. And you can see some terms here. You can see u, you can see v, you can see a, you can see s.
Sir, you can't hear it now.
Okay, can you see the screen I'm sharing? Maybe it's the network. Can you see the screen I'm sharing now?
Yes, sir. Yes, sir.
Okay. So please don't write. Don't write. Just listen. Just relax. Okay. Now,
Yes, sir. Yes, sir. Yes, sir.
okay, fine. So
Yes.
we have this as initial velocity.
Network is bad, yes, sir.
Oh, I guess as much. I guess as much. So we have initial velocity here. Then we have final velocity. Then we have acceleration. And we have displacement.
Sir, the TKS is for what?
What did you say? Oh, maybe you are not seeing what I'm writing. Okay, let
The
me just.
UVA, UVA.
Yeah, these are the terms.
I saw it, bro.
these are the terms of the equations, okay? I mean, from all of the equations, we can see U, we can see
Okay, sir.
we can see A, we can see T. So what they stand for is what I'm trying to write. So we have T also standing for time taking.
Okay, sir.
Yeah, time taking.
Okay.
So um, we are going to continue shortly. Please write down what is on the screen, okay?
Okay, sir.
Yeah. Once you finish, you tell me. All right.
Okay, sir.
I'm going to continue shortly.
Is it not?
Want to quickly derive them. We want to quickly derive the three equations of motion, but before we go into the derivation, I would like to explain some basic terms, okay?
Okay, sir.
Yeah, the basic terms I want to explain are the terms we'll be mentioning, like when I say velocity. Velocity. It is the rate of change of displacement. Displacement, the rate of change of displacement with time. Then, when we talk about acceleration,
Is the movement of an object?
it is the rate of change of velocity.
The movement of
Acceleration is the rate of change of velocity with time. And time itself is a duration, and displacement is like a covered distance in a specified direction. Displacement S, the symbol for displacement is letter S.
Yes.
Meanwhile, velocity is V, acceleration is A. So displacement S is the distance, the distance covered in a specified direction. Distance covered in a specified direction. So talking about velocity, we can say velocity V is displacement over time. You know,
Okay, mathematical expression.
yes, displacement over time. Talking about acceleration, we say acceleration is the rate of change of velocity. So acceleration is going to be final velocity minus initial velocity over time.
Yes.
So from here, if you make V the subject, if you make V the subject of the formula, you're going to have to cross multiply from A equal to V minus U over T. You cross multiply, or you multiply both sides by T first, times T, then times T. So T cancels T here, divides, and we have AT equal to
Yeah.
V minus U. Then, since we're looking for V, we want to make V the subject, then we have to take U to the other side. U was negative here. So the negative U will come here to become positive
Yes.
U. So that's AT
Positive.
plus U equal to v.
Plus u equals to v.
Very good, very good.
To v.
So we can now say that
Means
v
u equals
equal to u plus at. That's the equation 1, okay?
u plus t.
U plus at.
Yes, sir.
Very good. So let me move. I want to move this up a bit so that I can have enough space to write at the bottom there. Okay. So now, here is what I'm trying to say. I'm trying to say that finally we can say v equal to u plus at, and that is equation 1. So we've proven the first equation of motion. If you are asked to prove it in a test or an exam, they can say, okay, show that v equal to u plus at. That's all. What they're trying to say is that you should prove v equals to u plus at, or you should prove the first equation of motion. So what you need to do is to define acceleration. Is to do what? Define acceleration by formula.
Define for
So, and that is a equals to v. You want to say something?
No, it's not right the definition of time. That's what I'm asking.
Okay.
Definition of time.
Time. I told you. I said time is just the duration of an event, okay? And in exam,
Okay.
it's rare for them to say you should define time. They would rather ask you to calculate time, okay?
Okay.
So now, acceleration is v minus u, which is change in velocity. You know, in some expression, you could see acceleration equals to delta v over t. That is
yes,
change.
that is velocity. Or velocity.
Yes, change in what? Velocity.
Velocity.
Yeah. So over time. So we can now say change in velocity will be at, and that's what we did here. Is that clear?
Yes, sir.
Okay. Please jot down whatever is on the board. Once you finish, you let me know.
Okay, sir.
All right. Okay, now to the second equation of motion. What's the second equation of motion again? That is s equals to ut plus half at squared. Okay, fine. This is what we want to prove. S equal to ut plus half at squared. You know your S is displacement, initial velocity, acceleration, and time. So to get this, we need what is called average velocity. Average velocity, which is v plus v minus u. No, not minus, v plus u, because you are finding average. V plus u over 2. But remember, when we were defining velocity, we said it's a displacement over time. Displacement over time. So this is displacement over time.
Yes.
Then we want to try to make S the subject. Then what we have is to, like cross multiply. If you cross multiply this way, you have t times all these and 2 times s. So you have 2s equal to u plus v times t. Are you getting this?
Yes, sir.
Very good. But remember, we already have our v in equation 1 as u plus at, okay?
Yes.
V equal to u plus at, so we'll plug it in there. So we have 2s equal to u plus the u plus at, then times the t that is outside. Then we can, open that bracket. So we have 2s equal to u plus u is 2u, then plus at times t. Then we have 2s equal to 2u times t is 2ut. Then at times t is at squared. Very good. So we now divide everything by 2. 2 cancel out here. Hold on. Then we have s equal to 2 cancel out here, ut plus anything over 2 is half of that thing. So half at squared.
Yes.
Is this clear to you? Do you understand it?
Yes, sir.
Okay, very good, very good. So you can put it down. Once you finish, you let me know. So this is the second equation of motion. So we can say we have derived the second equation of motion. Equation 2. Yeah, I know. I just said you should hold on. Now, this is second equation of motion. So what's the third equation of motion? V squared equal to
Third
u
equation
squared.
is v squared
is equal to u squared plus 2as.
Very good. So that is what we want to prove now. V squared equal to u squared plus 2as. The same thing that we used when proving the second equation of motion, which is average velocity, is what we're going to use.
average velocity.
Yes, that's what we're going to use. But this time, we're going to need the formula for time. So I can just copy this, so that we can see that, okay, it's the same thing we're trying to use. So I can copy this and take it down there. So once I'm here, then I'm going to do justice to this. Now, to cross multiply this time around, it's V that I am concerned with. But before I try to get concerned with V, I need to get rid of T because there's no T in this, right? Right? Do you get that?
Yes, sir.
There's no T. So this T has no place.
Yes, sir.
Yeah, this T has no place here. So where can we find T that we now have to use something to replace the T? We'll go back to the first equation. First equation of motion, we say T, okay? So when we get back to the first equation of motion, we will now find T from that equation. We'll make T the subject of the formula. From here, we can find our T by saying V minus U over A will give me T. So this T is going to be replaced with V minus U over A.
V.
Very good. V minus U over A. Now, this is what I'm going to write. V plus U over 2 equal to S divided by T. Then V plus U over 2 equal to S divided by T. This is T now. So I'm going to move this T. The value of T,
Yes.
I'm going to move it here to represent the T, okay? Then in my division stuff, I can flip that division to multiplication. So it's going to be S times A over V minus U.
And you V minus U.
Very good. So v plus u over 2 equal to s times a will be as, then over v minus u. Here, I can cross multiply. I would say v plus u times v minus u equal to 2 times as. That is 2as, okay? Then I
Yes.
can open the bracket. V times v is v squared. V times negative u is minus uv. U times v is plus uv. Then u times u negative is negative u squared equal to 2as. Then we can see uv minus uv is gone, so we have v squared minus u squared equals to
V square
2as.
minus V.
Then we have
Okay, we move you
to the front.
across the equals to.
Yeah, but we
This is
didn't
V
cross.
equals to U square.
Yes, we did not even. We eliminated this, right? Okay.
Yes.
So this
So
it
you
now
move.
it now remains this. So we now have v squared equals to
Yeah,
u squared
equals
outside
to
plus
U square.
2as.
Oh, yes, sir.
So this is equation 3,
The beginning.
right?
Okay, sir.
Is it clear to you?
Yes, sir. Yes, sir.
So if you see it in exam or in test, they say you should prove the 3 equation of motion. What you're going to do is very simple. The first one, you define acceleration. Okay? When you define acceleration, you make v the subject in that formula of acceleration. Then you have your equation 1. Then the second one, you define average velocity, like v plus u over 2. Then you know the definition of velocity as displacement over time. Then the displacement is s,
Yes, sir.
time is t. Then once you cross multiply and whatever we did there, we replace v with equation 1, okay?
Yes, sir.
So that alone was able to give us, this equation. Then the third equation, the same average velocity, displacement over time, but we have to get rid of the time. So we went back to equation 1 here and find a formula for time by making t the subject. So we now plug in
Time.
what time is, we plug it here. Then we're able to get this equation. Okay, once you finish putting it down, you let me know.
Okay, sir.
What's next now? I want to ask you some questions here. This based on what's on the board, I want to ask some questions. What does V stand for?
Okay, sir. V stands for velocity.
Are you sure?
Yes, sir.
Or you would say final velocity?
Oh, yes. V stands for final velocity.
Good.
U stands for.
What about you?
U stands. U is in initial velocity.
Good. Please, what is the meaning of initial and final velocity?
Initial is like the beginning.
The beginning. That's a very good one. That's Kingsley, right?
Yes, sir.
Initial velocity. Okiki, are you also getting it?
Yes, sir. Yes, sir.
Okay. Initial velocity is the starting velocity of any journey. So let us assume that the object was not moving at all. At the beginning of the journey, it wasn't moving. Then all of a sudden you ignite it and you accelerate and it starts moving. So the initial velocity will be 0. Okay? Because it was not moving.
Yes, sir.
It was not moving. It was at rest. So any object at rest, don't
Okay.
tell me that it doesn't have a velocity. The chair you are sitting on has a velocity of 0.
The velocity is 0.
Yeah, but at a certain level of physics, they will tell you that the velocity of that chair is not 0 because it is on the earth and the earth is moving. Okay? Do you understand?
Yes, sir.
Okay, good, good. But for
Yes, sir.
but for this purpose and for this linear linear motion, u is 0 for an object at rest. Then v is your final velocity or an instantaneous velocity at a particular instant where you refer to the motion and say, okay, it has traveled for 5 minutes. Then the velocity you want to mention after the distance has been covered is a kind of a final velocity. Okay, what is the unit?
Velocity.
Yeah, what is the unit of velocity? You know we have units of measurement, right?
Yes.
Units of what? Measurement. For example, you measure time in seconds. What else do we measure?
In seconds.
So we measure velocity in what? We can measure displacement.
Meter per second, sir.
Yes, meter per second. We can measure displacement s in displacement s. We measure it in meters or kilometers. And this is bigger than this because you would need 1,000 of meters to get just a single kilometer.
Oh. A single kilometer.
Yeah, just 1 kilometer. Now, we mentioned acceleration. What is the unit of acceleration? Velocity v times t, acceleration a. So what's the unit of acceleration?
Acceleration is
Meters per second square. So you should be able to differentiate between this and this, okay? Is that clear? So
yes, sir.
please put down these details. Then we are going to look at some questions that we can solve using equations of motion. We concluded that when direction is involved, we make use of velocity. When no direction is involved, we mention speed, no direction. And both speed and velocity can be measured in meter per seconds and meter per seconds, but acceleration is meter per second square. Or they could say centimeter per second square. It doesn't matter, but meter or centimeter. But the standard unit is meter per second square. Also, we can say that speed or velocity can be measured in kilometer per hour, centimeter per seconds, meter per minute, or miles per hour. What's the full meaning of MPH?
Mile per hour.
Mile per hour. Good.
Mile per hour.
Very good. Very good. So I want us to let me check this question page that I'm trying to bring up. Can you see the page I'm sharing here?
Yes.
Okay, let's do it this way. Let's pick it one by one. Okiki, read the first question.
What is the name of the type of quantity that has one magnitude size.
That has only magnitude or
Actual
size.
answer.
Yes, yes.
Vector.
Oh, let's check the answer. Scalar. Okay.
Yeah.
So that means vector quantities must have both magnitude and direction.
Our direction and magnitude.
Very good. But scalar quantity has only magnitude. Is that clear?
Only magnitude. Yes, sir.
Very good. Okay, take note of that, and Kingsley too. Kingsley, your question is next. Read it.
So, chematic equations, which is chematic equation, aka equations of uniform motion, can only be used when you have a constant
Dash.
velocity.
Okay, let's check the answer. Acceleration. Okay.
Oh,
So let's take note of that. That we use equation of motion when we have constant acceleration. Is that clear?
acceleration.
Good.
Yes.
Good. Okiki, next question.
Sir. Yeah. The graph represents the motion of a train travel between two stations. Which statement about the train is correct?
Hmm.
The acceleration is a long time than its accelerate. It travels constant speed. Sir, purple, the purple one.
The purple one, right?
It travels at constant speed for less than half
That's correct.
of its journey time.
That's correct.
Yes.
Yeah. So now, Kingsley, the next question is for you.
The graph represents the movement looking right. Sir, is a unit of acceleration. Is a mass per second square.
Did you say
I
mass?
say mass. Meter per second square.
Okay, meter per second square unit of acceleration.
No, meter. It was a mistake.
Okay. So, Okiki, do you think you can attempt this?
An airplane accelerates down a runway 3.20 m square runway. Unit finally lifts off the ground. This distance travel between take off. Which of the equation is appropriate? Yeah.
And it was
Is this one green?
Green,
The
right?
green one.
Wait.
Yes.
The green one says change in displacement equal to initial velocity plus final velocity over 2 times t. But the purple one says ut plus half a t square. That's velocity time plus half a t square. This is the third equation of motion, okay?
Third equation of motion. Okay.
Yes.
Yeah, Kingsley.
Kingsley, over to you.
sir.
Yeah.
Roller coaster accelerates from an
Initial.
velocity of 6.0 meter 6.0 meter per seconds to a final velocity of 70 meter per seconds over 4 seconds. What is the acceleration? I want to calculate it, sir.
Okay.
What is the acceleration? Acceleration is
Did you remember the formula for acceleration?
Yes. Velocity minus u over time.
Okay.
So the final is 70 minus 6 over 4,
4.
which is 68 over 4. 68 over 4. Yes.
Wait, do your subtraction again.
Oh, 64.
If it's exam now.
64.
Okay. So, what's your answer?
I'm going to no my calculator. That is we cancel this one in cancellation. That is 2. That is 18.
Are you sure? 64 divided.
Yes. No, it's 64 divided by 4. 64 divided by 4. That is. Oh, let me understand. 64 divided by 2 is 32. 32 divided by 2. 32 divided by 2 is. Oh, it's 16 meters per second.
Wait, before I choose the answer, is it option C or option D?
It is D.
Are you sure? What are you looking for? Is it velocity or acceleration?
Acceleration. It is C.
C.
No, simple. Yes.
So that means whenever you're in exam hall, you should always calm down, okay?
Okay, sir.
Okay, let me see. Hold on a bit. Next question is for Okiki, right?
Yes, sir.
Now, Okiki, once you see the question, you read it.
A golf ball starts with a speed of 2 meters seconds
2 meters
per second and slow at a constant rate of 0.5 meter per second square. What is the velocity after the 2 seconds? Which can I get is? Time coming, let me calculate it.
Okay. The first thing you need
V is equal to U plus A.
Good.
So, okay, V is now what?
V is the velocity.
V is what you are looking. Wait, you are looking for V. You are looking for V. So continue now.
V. But we use to happen. Maybe some question that way from you is soon. You is 2 and Guinea is 5. What's it called? And he is 5. What is the solution? The solution is 0.5. 0.5 times.
Wait, U is what?
2 plus.
You can say U is 2, right? That's the initial velocity.
Yeah. Sam is going to paper. 0.
But wait,
I
think the question is for Okiki now, right?
Yes, sir.
Yes.
How can I make my calculator?
Okay.
Time coming.
Okay.
Yeah.
Going to check it.
Wait, which formula are we going to use? Formula will
It's equation 1 now.
Equation 1, you are right, Kingsley. It's equation 1. But Kingsley, it's like you are confused because your answer is not in the option, right?
Yes, sir.
What's the answer you got?
I got 3.
3.
Yes.
You are right based on what you did. Your process is correct, but you missed a point from the question. And what answer
Okay.
did Okiki, what answer did you get?
2.5.
2.5, because you did not even care to follow Bodmas. Okiki. You said, because I heard you said, what did you say again? You said 2 plus 0.5, right?
Yes, sir.
But if you have your equation, which is v equals to u plus at, you're supposed to
80.
multiply this first, right?
Yes, sir.
That's according to Bodmas. You do multiplication before addition, like Bodmas, like this, Bodmas.
Addition.
So multiplication come before addition and subtraction, okay?
Addition. But
Now,
Yes, sir.
let us assume you were supposed to do that. You would have done it the way Kingsley did it, which is to say that you have your initial velocity u, very correct, then plus acceleration 0.5, which is okay, times the time taken 2 seconds. It's at, so time taken is 2 seconds. So you firstly multiply, you say this times this will give me 1, okay?
1. Yes,
Then
sir.
plus 2, then you would have gotten 3. But there's a point we miss. Slows at a constant rate. It did not, it's not increasing in speed, okay? It's retarding.
Okay.
It's not acceleration,
It's
but
decreasing.
retardation.
Hmm.
We could have acceleration or retardation, okay? Acceleration is for when you want the journey to keep going. Retardation is for when you want to come to a stop. You now slow down, okay?
Okay. It now be divided by 2.
Wait, it is
It is divided.
subtraction you are going to use instead of plus.
So try. Oh, 2 minus 1. The
Yes.
answer will not be 1.
Yes.
Oh,
Do you understand now? So if it is acceleration, if
Yeah.
it is really acceleration you're looking for, your answer will be 3, which is very good. 3 meters per second. But because it says it slows down.
Wait, let's write it down.
Sir.
Okay, yeah, that's good. So this is what you're supposed to write down. You say
Oh.
V equal
Sir.
to, yes.
What if during exam I wrote it like this? 2 plus open bracket minus 0.5 close bracket times 2.
That's correct. Okay. So u minus it, because of slowing down, you say u minus at. Then now say v equal to what's u? 2 minus
2.
0.5 times 2. Then v equal to 2 minus 1. So v will now be 1 meters per second. That's clear, right?
Yes.
Very
V equals to
velocity. Then state the units of the two quantities above. Then a cyclist riding at a speed of 4 meters per second slows down at a constant rate of 0.8 meters per second square. Excuse me. At what velocity was he riding after 5 seconds? Or find its velocity after 5 seconds. So once you're through with that, then it means you are free to go. And
Actually, it's the equation one we're using.
yeah, it's the same question. I didn't change the question. Look at it. Look, let me show you.
Okay.
Let me show you. It starts with the speed of this, right? Right?
Yes.
Slows down at a constant rate of
Okay.
this, right? Then find
Yes, sir.
whatever you are finding. Find velocity, right? After
Yes.
how many seconds?
Okay.
So you can do it yourself, right?
Yes.
Very good. Very good.
Done.
Okay. You can
SS.
let SS1 come over. Ajibola, yeah.
SS1 will be coming over.
Okay, yes.
Sir.
All right.
Sir.
Kingsley, yeah.
The physics quiz you just did, which link is that? What's not?
Oh, it's called quizzes. Or it's called Wayground. Wayground, okay?
Okay, yeah.
Okay.
Wayground.
Yeah.
Okay, sir.
Yeah.
Background.
Yes, Wayground.
This is Wavie.
Okay, sir.
All right.
Goodbye, sir.
All right.
I don't cut it though.
I know. So see you next time.
All right.
Yeah.
SS1 are coming.
Yes,
SS1 are
I'll
coming.
wait for them. Yeah. All right. I'm going to continue shortly.
Yes,
Okay, please, I want you to concentrate so that you don't miss a thing, okay?
Okay.
Now, laws of motion, basically there are 3 laws, okay?
Yes, sir.
There are 3 laws.
Yes,
Isaac Newton's
Yes,
laws
sir.
of motion. Please don't write anything. I'll give you time to write later. So Isaac Newton's 3 laws
Okay,
of
sir.
motion. The first law, it says that every object will continue to be
Yes, sir.
in its state of uniform motion or rest unless it is acted upon by an external force. Wait, I need to adjust something there. It will continue to be in its state of rest. Or why does it even matter? Anyway, in a state of rest or uniform motion. Every object will continue to be in its state of rest. Somebody is talking. Who is that person talking? Okay. All right, please. At the end of this class, I want all of you to be able to, tell me the law without having to beat your head. Every object will be in whatever it has been unless something disturbs it. Every object will continue to be at rest if it was at rest, or it will be continue to be in uniform motion. Motion means you're moving, right? So
Yes, sir.
it will continue to be in its uniform motion unless it is acted upon by an external force. Let me ask you a question. Before we come back to this, has anyone defined force for you before?
Yes, sir.
Okay, who wants to try? What is a force or what is force?
Force is
Yes, please. Yeah. Yes, I can see your hand.
It's applied to motion. Stop. Okay, force means a push or pull of an object.
Okay, force is a
It's the
push
push or
or
pull
pull. That's a very good one.
of an object.
That's a very good one.
Thank you, sir.
So I would say
Yeah.
somebody is still talking. So I would say force is a quantity that changes the position of an object. Of an object. Meaning that without force, there would not be a change in the position. Force is a quantity. Somebody is still talking. Please make sure you concentrate. Make sure you concentrate. Force is a quantity that changes the position of an object. If an object is not acted, if there is no force acting on an object, then the position of the object will not change. So Newton's first law of motion says that every object, let me hear you, everybody.
Every object will continue to be in a state of rest or uniform motion internal force.
Yeah. So if it's not acted upon by any force, then it will remain. For example, at the front of your house, if you put a bag of money at the front of your house, a bag of money. Are you listening?
I'll tell you. Excuse me, sir.
Yeah.
Excuse me, sir.
Yeah. Yes.
Sir, please, I want to ask.
Please ask.
Question.
Ask.
Okay. My question is, okay, so I said that force is the quantity that changes the position of an object.
Good. Good.
Sir, so and motion. Yes, and motion is the change of an object. Sir, so what's now the difference between the two?
Between force,
motion
okay,
and force.
Very good. Force produces motion, okay?
Okay.
You understand now? Force
Yes, sir.
produces motion. So without force, there is no motion. Without force, there is no motion. But not all forces are able to actually change the position of an object because the force might not be enough to change the position of that object.
There's no motion.
Yes, without force, there's no motion.
Okay, sir. Please, motion.
I want those boys
okay,
to please
sir.
concentrate. I want them to concentrate.
Boys, concentrate.
Yes,
concentrate.
No. It's not like that. Okay. In every class, girls are often more serious than boys. That's why.
Yes, sir.
That's why my attention is on the boys. I want to make sure they are concentrating.
Choose something, yeah. Okay, sir.
Good. So every object will continue to be in a state of rest or of uniform motion unless it is acted upon by an external force. That is Newton's first law of motion. Okay. If you want to jot it down, please do. The moment everyone is through, you let me know. Okay, you've written it, right?
Okay, sir. Yes, sir. Thank you, sir.
Of motion, everybody.
Yes, sir. Objects will continue to be in the state of rest or uniform motion unless it is inverted or course.
Yeah. So Isaac Newton's first law of motion states that every object will continue to be in a state of rest or of uniform motion unless an external force acts on it. Okay. Now to the
Yes, sir.
second law of motion. Second law. Okay, let me say. States that the rate of change in the momentum of an object is
Momentum.
momentum. We're
Question.
going to look at the meaning later. Okay. Let me write it very well. It's momentum.
Okay, sir.
Momentum. So the rate of change in the momentum of an object is directly
You wrote is. Yeah,
okay. I wrote is twice, right?
Yes, sir.
Hold on. So the rate of change in momentum of an object is directly proportional
Where's good level? Where's that my bring it. I would not written it over.
no problem. No problem.
Yes, that's right.
No problem. Directly proportional to the force applied. And it, which is the change, and it takes place
God do not allow to go into Jesus' name. Amen.
in
I know what you are thinking.
the direction of the force.
My brother is 16. It's not necessary.
Please, I need you to listen. Please listen. Rate of change in the momentum. Momentum means energy,
Okay, sir.
which is calculated by multiplying the mass of the object and the velocity of the object. That's why you can talk about initial momentum and final momentum. Or let me just write it at the bottom. Say note.
I wish I was 15. That's which one?
No.
How would I pay?
Momentum. Hey, you guys are making noise. Do you know? Momentum equal
You
to
guys are making
mass times velocity, which is a form of energy. So momentum is mass times velocity, which is a form of energy. So the rate of change of the energy of a moving object, okay? Can you hear me?
Yes, sir.
If an object is moving, and another object pushes it from the back, then the moving object will jack forward, right?
Yes, sir.
If an object is moving, let's say
Yes, sir.
A boy is running and another boy pushes him from the back. The boy that was running will jack forward with an increased energy. So the rate at which it's going to jack forward, somebody is talking there. The rate at which it's going to jack forward.
Sir, is necessary.
Okay, they are not part of your class. No worries.
Yeah.
No
Sir.
worries. Okay. So the rate at which the person that was running initially is going to jack forward will be directly proportional to the applied force. It will be directly proportional to the applied force. So, rate of change of momentum of an object that is moving will change based on the applied force. Listen again.
Yes, sir.
The rate at which the speed or the energy of a moving body, will change will depend on the applied force. That is, if no force is applied, the momentum will not change. But if you apply a force, if the force is small, it will create a small change on the momentum.
Yes, sir.
But if the force is great, it will also create a big change on the momentum. Let's take it this way. If an object is moving and a bicycle rider was coming behind the object, the bicycle rider now kicks the object forward. And the same type of object was kicked by a trailer or a truck. You will know that the one that was kicked by a truck is going to fly off more than the one that was kicked by a bicycle. So the rate of change in the momentum of an object is directly proportional to the applied force. What does it mean? What do we mean when we say directly proportional? What we're saying is that the greater the applied force, the greater the change.
The greater change
in the momentum. You understand?
Yes, sir.
So the greater the force you applied, and from this law, the greater the change. From this law, we have what is called. Please make sure you concentrate. Those boys are busy talking at the back. Please concentrate. We have mathematically, force is directly proportional to the rate of change of momentum. MV is final momentum, while MU is initial momentum. Remember, I said momentum is mass and velocity, right?
Yes, sir.
MV. So, change occurs when we have a final momentum minus an initial momentum, okay? Yes.
Yes, sir.
So, final minus initial over time. That is what this law is saying. That is, the rate of change in the momentum of an object is directly proportional to the what? Applied force.
To the applied force.
Let me write that again so that you can see it clearly. Alternatively, we say the rate of change of momentum is directly proportional to the applied force. But when you want to spell out the change in momentum, this will be mv minus mu, and that's where this one comes from, okay?
Yes, sir.
Over time. Then we can factorize this expression. We can factorize the expression by saying from F proportional to mv minus mu over t. Yes.
Sir, please, can you explain the one you wrote with pink? I don't understand.
Okay. That is what I was saying all along. I said,
Yes.
hold on. Let me try to take it back there now.
Is it the same thing?
It's the
with
same
the
thing.
first
I was
one?
just trying to say, if you don't write it this way, you could find it this way.
Okay, you can write it this way. Okay.
Yes. So this
Sir,
data,
but you still get the character.
wait, this
You
triangle,
still get the character.
yes,
You get the same answer.
yes.
Okay.
This
Sir, you can
triangle,
go on about that.
hold on. This triangle is used to say change.
Yes, change.
Yeah, change in momentum over time, proportional
Time
to the force.
varies.
Do you understand now?
Yes, sir.
And before I said force varies directly as final minus initial, which is change over time. Okay.
Change, yes, over time.
Good.
Yes, sir.
Now, I now wanted us to look at something before you write anything down. Make sure you concentrate. They can ask you in exam, maybe like a question. They will say,
Yes, sir.
prove that F equal to MA. Have you seen this formula before?
No, sir.
Okay.
Yes, sir. No.
F equal to MA. You might have seen it, you might not have seen it before. Yeah, but that's not even a problem now. It's good as you said no,
Yes, sir.
if you have not seen it, and it's good as you said yes,
Have to.
that you have seen it.
If you have to. Yes, sir.
Good. What about the boys? Have they seen this formula before?
Have you
No,
seen
sir. I'm answering you before.
Okay. Now, if they ask you this question, please listen so that you can know what to do, okay?
Okay, sir. Yes, sir.
You are just going to go to this second law of motion and say that, okay, rate of change in momentum.
In the momentum of an object.
Yes, rate of change. You write it, that rate of change in momentum of an object. Momentum, yes, TUM, momentum of an object is directly proportional to the force applied, okay? Is what?
Directly proportional to the force applied.
Good. So you are going to put directly proportional to force.
Yes, sir.
Then, since you said this is change, you will now represent your change like this. Change is final momentum minus initial momentum all over time. Then varies as the force. Or you can twist it around and say force varies as mv minus mu over time. Please
Over
make sure you are
time.
concentrating.
Yes, sir.
Then F, you factorize this. You do what?
Factorize.
What is common to this?
M.
M
M is common.
into V
Yes,
minus
sir.
U over T.
Yes, sir.
If you remember the definition of your acceleration, acceleration is rate of change in velocity with time. Acceleration is V minus U over T.
The increase of change of velocity.
Then, in our expression, we have M times what? V minus U over T, right?
But yes,
Can you
yes,
see
sir.
it?
So
So
you have
F,
separated.
yes. Can you see it?
Yes, sir. Hey, I got it.
So now, M times, what is this? Acceleration, right?
Yes, sir.
So instead of putting this, you now put acceleration. Then you say F is proportional to mass times acceleration, okay?
That's how they got it.
Then in proportionality, if you must put equal to, there must be a constant.
Yes.
So you now say where constant is 1, because nothing hinders the law. Then we say F equal to 1 times MA, then F equals to MA.
Okay, that's how they got.
That's how they got the formula F equal to MA.
Thank you, sir.
Okay, so have you written this second law?
Yes, sir. So we learned that. Sir.
Yeah?
The second formula. We want to write it.
I mean, this law, have you written this law?
Yeah, we can repeat it.
Okay, okay.
The second law.
Now,
We want to write formula.
yes, you can write it now.
Yes. Sir.
You're saying something?
Start. Yes, sir.
What's that?
Sir, please, when there's a part where you wrote mathematically.
Yes.
F varies. Yes, sir. Now if you use that formula, if it's that F varies mu minus mv over time, that yes, and we can use that F equals to FA. So are we going to get the same answer?
Yes, yes, you get the same answer. Because this is it here, okay?
Okay. So I've got to.
No problem.
So, but how do you not get NV minus when it's when now? Yeah, perfect. It did not end till. Is it?
Okay, continue. Third law. I don't know if you can hear me. States that to every action, which could be a motion, or something, to every action, there is an equal but opposite reaction. Okay, you are connected back, right?
Yes, sir.
Okay.
Thank you.
So to every action, there is an equal but opposite reaction.
That's
Where's my pen?
And that is the law. As simple as that. To every action,
Stop it, another.
wait, calm down. To every action, there is an equal but opposite reaction. Let me put it this way. If you hit your hand on the wall or on the table, or if you use a ruler, please listen.
Yes.
If you use a ruler to hit your hand,
Yes.
you have performed an action.
Yay!
Listen.
Sir, what is it?
is that not the body?
Can you hear me?
Sir,
So if you use a ruler or something to hit your hand, you have performed an action by transferring energy to your hand from the ruler. And your hand has performed an action by receiving the same amount of energy that you transfer from the ruler. Somebody is talking there.
It's not that thing now.
Get out.
Okay, how are you? All right. Okay. So be the best, okay? Just be the best. Yeah, be the best. Now, listen. If you use a ruler to hit your hand, can you see? I'm using my hand to hit the other hand, right?
Yes. We cannot see.
You can see. Can you see it? I'm using one hand to hit the other one, right? So, as the right hand is going down, it's passing energy to the other hand. So one action is the transfer of energy, and the other action is the receiving of energy. So the energy transferred will be equal to the energy received. What did I say? What did I say just now? I said the energy transferred will be equal to the energy received. Hope you can hear me. Those who are talking should keep quiet a little so that we can concentrate.
So I said,
I said to every action, there is an equal but opposite reaction. This E was not, opposite reaction, okay?
Yes, sir.
So if I use my right hand to hit my left hand like this, the right hand transfers energy to the left hand. The left hand received the energy. So there is an equal and opposite reaction. Can you hear me? Can you hear
Yes,
me?
sir.
Yes, sir.
If you are in a taxi,
Yes, sir.
if you are in a taxi or in a
Yes, sir.
vehicle or in a school bus, if the driver suddenly matches the brake, the driver wanna move, like, stop the motion, which is a backward motion, the passengers will jack forward. That is an equal but opposite reaction. So if the driver matches the brake slowly, you jack forward slowly. If the driver matches the brake with force, you jack forward with force.
Yes, sir.
If the driver accelerates slowly, you jack backward slowly.
Yes, sir.
If you're on a bike, have you taken a bike before?
Yes, sir. No,
If the rider accelerates forward, what happens to you? You jack backward, right? You're saying something?
Yes, sir.
Okay. So, What do you want to say? Yes, let me hear you. Yes, let me hear you. I can see your hand up. Let me hear you.
Sir, please, I want to ask sir. Sir, when you sir, what's now when you said that there is an equal but the opposite reaction? Sir, is it that let's say the when you were talking about the taxi that if the driver press the brake, that if he press it fast, first they will go far. Sir, but it can be let's say is it possible for the people for them not to jack with the car jacking or with the car going fast?
You could control yourself, but the tendency to jack forward is already there.
Sir, if you now use seatbelt,
Even with seatbelt, you still jack forward. You know, the seatbelt is not going to hold you like an iron cage. You understand me?
Yes, sir. Yes, sir.
Aha. It is when if it's something that holds you like an iron cage, fine. Now let's talk about this.
Yes, sir.
Bus travels past a tree, okay?
Yes, sir.
The tree travels past the bus with the same speed.
Eh? Sir, how will a tree travel past the bus?
Read the first one.
Bus travel past tree.
So the tree also has
The
traveled
tree
past the bus.
travels past the bus with the
The tree.
sir, please, how?
Wait. When you are traveling and you're in a bus, then if the bus move very fast, they will move very fast. If the bus slows down, they will slow down. And that is what equal and opposite reaction represent. Is that clear?
Yes, sir.
Because the earth is rotating, she's not listening, right? Because the earth is rotating, the sun appears to be moving in the sky. Yes or no?
Yes,
So, but the sun is actually not moving, but it is moving. Even the clouds appear to be moving because of the rotation of the earth. And that is where we'll be rounding up for today, okay? See you
yes, sir.
next Wednesday by God's grace. So, goodbye for now. Goodbye. Yeah.
Yes.
All right, viewers. Thanks so much for watching. You can subscribe to this channel for updates on our future videos. Goodbye for now.